to sell voice over IP products, we realized quickly that people bought them and hooked them up to what they already owned, like a voice system from Nortel, you know, Alcatel, Avaya, whoever, and they were having trouble making it work. So we found that Cisco's Technical Assistance Center, TAC, is getting more and more calls on how to make our stuff work with competitor stuff. So we set up this lab back in '99 and started buying competitors' voice gear, and we do interoperability testing. So we hook their stuff to ours, we play around with the config on both sides until we get what we want, maximum feature transparency. And then we run an app node and put it on Cisco.com. We're not making much, doing a whole lot of work about keeping it neat and clean, but it is productive. The PBXs in here, and you know what that is, right? Private branch exchange, old world phone systems. They tend to be in proportion to how often we encounter them in the real world. So there's a lot of Nortel stuff. They may be bankrupt, but their stuff lasts forever and it's still everywhere. These are two working Alcatel systems. The big three in Europe is Alcatel, Ericsson, and Siemens. We have sample phones that work with the systems. We usually have the operator console, which is bigger than normal phone, so when you dial O, you get that, and it allows you to switch calls, put them on hold, and basically handle calls really fast. It has T1E1 cables, as well as 8-pin modular jacks that we're using for everything from ISDN to analog phones or whatever. So we can take anything we want from these phone systems and run it over. That's what those are? Yeah, these are standard, pretty much international standard T1E1 cables.
Oh, okay. Never saw that.
It's called Bantam, because it's a miniature of the old jack from 100 years ago. Which I don't know if there's any full-size ones around.
Wow.
They're still big by modern standards, but yeah, this is like, I don't know, 60s technology.
Those tight cables in the military back in the radio shacks, patching stuff in.
People still use it. So I'm not going to point out every phone system in the lab, but it's worth pointing out here. This may look like Cisco Call Manager servers, but it's not running Call Manager, it's running Microsoft Lync, LYNC. Cisco and Microsoft are partners, so we do a lot of interoperability testing between their soft phone, their VoIP, and ours. We even have products of Cisco that work on Lync, like Cisco's CUCI and whatever Lync. But we're also competitors because we're selling these voice systems to the same customers, so it's an interesting relationship.
Looks like the holodeck. I feel like I'm in virtual reality here.
So this is called a 10-meter semi-anechoic radio chamber. 10 meter means it's 10 meters from the center of the turntable to the farthest point that the antenna can go. And it absorbs radio energy. The chamber is made out of 2 layers of steel sandwiched over plywood. If you look up high on the wall, you can see there's 6-inch square gray tiles up there glued to the steel. That's ferrite, and it absorbs radio energy. And then lower down, glued to the ferrite tiles, is that black foam. It's black because it's impregnated with carbon, and it absorbs radio energy as well. So when signals come off the product being tested, which is always on the center of the turntable, it's absorbed by the walls, it doesn't bounce around, so we can get a true reading of what the radio energy is coming off the product. If it was just a plain steel room, it would bounce around and you wouldn't get the right answer. And if you don't have a steel room, you get to do this outdoors in a rural area in an open field, and then you have to subtract out cell phones and airplane navigation signals and things, and you can't get very good results. So the product here, powered up and operating, and we can run cables down into the basement and hook it up to bit air right test sets and things. The computer that runs the test will turn the turntable back and forth, and it raises and lowers the antenna. It's looking for the strongest signal, which could come off in any direction. And we're making sure that we meet all the various national regulations for unwanted radio leakage. So again, it's not a full anechoic chamber because we don't have absorbers on the floor. It's basically a very, very quiet room with no reflections off the walls and ceiling because we're trying to measure the fan noise off of our products. There are regulations that say the product can't be too loud, especially if you're going to put it in the phone company's central office because they don't want it to be too loud for their employees. So you notice we have a triple door here, the big one, the middle one, and this one. Now don't touch any of the cables or mics because it takes hours to get them set up in the right position and we don't want them moved by accident.
Oops, I let the door close on us.
Don't step on cables.
Yep.
So you can kind of tell it sounds dead in here because you're not getting any reflection off the walls. This is a real test. The microphones are arranged in a hemisphere around the product. So we get the thing set up, turn it on with the fan speed maximum, you can push a button in the other room and we get an instantaneous measurement on all the microphones. Then the computer calculates the total sound power emanating out of this hemisphere from the product. And we put that section in the data sheets, you know, how loud the product is. If you've ever been around some of our big stuff, like the Catalyst 6K or the CRS-1, they're really noisy. So we've had to kind of tone them down the last few years. Okay, so this is our shock and vibration lab. This is where we drop things and we shake things. We have 4 hydraulic cables here. The one over there is called the transportation vibration horizontal. It shakes back and forth. It's fairly low energy shake. What we're doing is simulating the shock, the vibration you get shipping a product on a train or truck. There are no shock absorbers on trucks and trains. And there's a reliability test. We want to make sure the thing still works after it's been shipped to the customer. So we're looking for things like the doors crack or the parts fly out of the sockets. This is the horizontal earthquake table. Notice the piston on this has about a meter of movement. We're doing a major earthquake simulation. It's swinging its way back and forth. We have recordings of real earthquakes on this control room computer, such as the 89 Loma Prieta earthquake that hit California and interrupted the World Series. And some of the testing we do, we actually the industry standard test dummy, and the chest has the same resonance as a human chest cavity. It has an artificial mouth, artificial ear, and you can test any kind of phone on it. You could put a cell phone or whatever.